one of the most important questions for any competitive exam, the compound that has highest ionic character. Now, if we look at the Fajans rule for covalent character in the previous question which we have done, smaller the size of the cation, larger anion, it will prefer covalent character. Now, this is exactly opposite. Larger the size of cation, smaller the size of anion, it will prefer ionic character. Now, the ionic character is influenced by electronegativity difference. So if there is a bond, say for example P and Cl, the electronegativity difference also plays an important role in establishing the ionic bond. Now if you look at the periodic table, the elements on the extreme right have high electronegativity. So extreme right has high electronegativity. The elements on the left side has comparatively lower electronegativity. So on the right, so these two or three characters you should remember. The elements on the right have high electronegativity. Elements comparatively on the left has low electronegativity. For example, the size of the compounds or the elements in this case, as we go across, the size of these elements goes on decreasing, and as we go down, the size of elements goes on increasing. So this is one point you have to remember, this is the second, and this is the third. So electronegativity on the right is high, electronegativity on the left side of the periodic table is low. Then as we go across the period from left to right, the size of these elements decreases. As we go from top to bottom, the size of this element increases. So now if you compare these four, so PCl5, this is present in the third group, as you can see here, third period, as we can see here. So this is the third period, as we can see. So phosphorus, third period. So but as boron is present in the second period, carbon is present in the second period. So as we go across, this is smaller, the size of this carbon will be smaller than boron. The size of silicon will be higher than phosphorus, because as we go across, the size decreases, as we go down, the size increases. So if we compare all these individuals of species or individual compounds in this case, we find that this silicon will have a maximum size. So larger the cation, smaller the anion. So anion, there is no question, because anion is same in all the case. So just a trick is, you have to trace, or you have to find out the largest cation in this case, and in this case it is SiCl4, silicon. So because of this reason, silicon, SiCl4, is considered as highly ionic in nature. Correct answer is D.